welcome back. In this segment, we're going to talk about geometry. So we're doing a little segment, just two little sections, 8.3 and 8.4 in your book. You'll have some homework problems over geometry using formulas and such. There's a handout in there with just some basic geometry formulas for you. What I thought I would do in this video is I would go through some of the sample problems off of your homework on your MyLabs program, some of the sample problems. Okay, so starting on 8.3, we're going to talk about area and perimeter mainly. So it starts out with kind of a review of some basic geometry thoughts. So I wanted to remind you that two angles that sum to be 180 degrees, I don't know what to write on the board for this, but if two angles add up to make a straight line, 180 degrees is flat. So if you were looking at just a straight line, that'd be 180 degrees. If you have two angles, like an angle here and an angle there, two angles that add together to make 180, we call that supplementary. Supplementary angles add to make 180. And then on number 2, and yours may regenerate out a little bit differently than these exact ones, but on my number 2, it says an angle whose measure is 180 is called A, and it's multiple choice, and they're going with straight. It would be a straight angle. If you were 180 degrees, it'd just be a straight line or a straight angle. Number 3, then we move to complementary. So let me talk to you about complementary angles. So this is considered a right angle. Right angle is a 90-degree, perfect little corner, square, we might call that angle. So a right angle. And then if you have two angles, like an angle here and an angle there, two angles that add to make that 90 degree, we call that complementary. So complementary angles add to make 90 degrees, supplemental add to make 180. So an angle that measures 90 degrees is a right angle. That's my number 3. Then on number 4, let's see, we shift gears and we talk about, not erasing well. We talk about obtuse and acute angles. Let me talk to you about that. An obtuse angle is more than 90. So obtuse would be like that is more than a square, more than a 90 degrees. So more than 90 is obtuse. An obtuse angle, that's my number 4. Okay, and then on number 5, if it's less than 90, like this little angle right here, this would be an acute angle. An acute is less than 90 angle. And then you have a picture on number 6, and it asks you to name whether that's straight. Of course, straight is 180, right is 90, acute is less than 90, like this, and obtuse would be this side, greater than 90. So in my picture, it's acute. I've got an angle that looks like that. Something that looks less than a 90-degree angle, so acute. Number 7 asks to give the complement of an 81-degree angle. So a complement, adds up to be 90 degrees. So if you have an 81-degree angle, again, this is my number 7, its complement would be how much would need to add to make, add to make 90. So you do 90 minus 81. If you're doing a complement, you just subtract that angle. So it would be 9 more degrees. A 9-degree angle would be its complement. All right, then we move into some of the formulas for area and perimeter after you get through kind of the base angle ideas. I hope this is going to erase. Okay. My number 8 looks like this. We've got a 4-sided figure, and we've got a perpendicular line drawn down, so they'll put a little mark there to show that that's 90 degrees. And it has 2 meters for this would be called the base. When we drop a perpendicular line down from the top of something, it's almost like a plumb line. If you think about it in construction, you're dropping something straight down to the bottom. We call that the height of an object, is the distance from the top of the object drops straight down 90 degrees with the floor, or the floor we'd call the base. So we would consider this to be the base of this figure, and this would be the height of the figure. So the perpendicular distance is always called the height. And we use that a lot in our formulas. You'll see H in the formula, that stands for the height, or the perpendicular distance down, which is usually drawn into the picture if needed. Then the other, it tells us this has a 24 centimeter height, and then a 30 centimeter on the sides, on that side. And then it tells us to figure out the area and the perimeter. Now, a problem with this one is they've played a little trick on us, maybe you'd think. They put this one in meters and this one in centimeters, so you're going to need to get the same units together. I'm going to convert my 2 meters into centimeters, so you might remember from our previous chapter that 2 meters would be the same thing as 200 in centimeters. You would be moving from meter down to centimeter, 2 places down, so you'd move the decimal 2 places right. So get it all in the same unit to use the formula. Then we have 2 formulas. The area formula for this would be a parallelogram. It's sort of like it would have been a rectangle, but it got pushed over on its side, so now it's parallelogram, so not perfectly square anymore. So the area is the base times the height, the area of a parallelogram. Parallelogram, I would call it. All right, so the base, we said, is this 200 centimeters. And then the height, that perpendicular distance, is 24 centimeters. So you'd simply multiply the base times the height together. When we multiply that, the 200 times the 24 is 4,800. Then centimeter times centimeter, you'd be multiplying, since it's a multiply formula, to find the area. And usually area is in square units, right? So we would expect square units for our area questions, and this one is centimeter times centimeter, which makes centimeter to the second, centimeter squared. So that's the area answer. I think that's the first question on A. Then the second question says figure out the perimeter. Perimeter is the distance around a figure, just the outside edges. It's a linear distance, this distance plus this, plus this, plus this. So it's an adding around the outside edges. So again, we want them to be all in the same units. So 200 centimeters, 30 centimeters, this should be equal up here, 200 centimeters, and then over here this should be equal, 30 centimeters. So adding 200 plus 30 plus 200 plus 30 adds to be, what is that, 460, and it's in just regular centimeters. Nothing got multiplied, we just added centimeter plus centimeter, so it's a linear distance around this regular centimeter. They could have asked us to give that in meters and convert it, but they did not. All right, so what's next? Number 9. Number 9 is a similar, so again, if you, you might not have this exact questions printed off, right? Yours regenerates different values. So in this case, I can't say, make sure you're watching the handout, because yours may look a little different than mine. Here's what my problem looks like, my sample number 9. I have a parallelogram, just like on the last one. I have 12 inches, 6 inches, and then my perpendicular height is 2 inches. Luckily on this one it's a little better, easier I would say, because they're already all in inches, so I won't have to do any converting to a like unit like we did on that last example. But otherwise it's the same question. And we're asked to find the area. The area of a parallelogram is the base times the height. So the base is where that plumb line lands, so 12 inches. Multiplied by the height, which is 2 inches. So in my example, 12 times 2 is 24. And when you multiply inch times inch, it makes square inches. So area is how much area or space is inside of a figure. So that inside area, you know, is going to be square units. 2-dimensional. Then for the perimeter, we just add all the sides, so 12, and this should also be 12 up here. If this is 6, this will be 6. So we add around that, 12 plus 6 is 18. When you add all that together, I get 36, and it's in linear, just measuring distance around, will just be in regular inches. All right, number 10. Having trouble erasing this marker, is powerful. Number 10, here's the figure. This is actually called a trapezoid, where you have a little base and then a big base. But one set of bases, the set of bases is parallel to each other. Again, that's called a trapezoid. So a trapezoid is a 4-sided figure, again, a quadrilateral example. To find its area, it's similar to the last one. You do base times height for all of these, whether it's a rectangle, a square, the parallelogram, the trapezoid, all of those are quadrilaterals, and to find the area is basically the base times the height. But in the trapezoid, the two bases are different. So instead of just being able to take one of the bases, we average the bases. Base 1 plus base 2, and then divide that in half or times it by half. So you average the bases, basically. So you can sometimes just look at it and say, oh, the average of the bases is, if this is 10 and 8, you say the average is 9. But the math of that would be add the two bases and half that, and then times by the height. So in my example, the numbers I have 4 inches for this base and 12 inches for this base. So maybe figure out the average of those. And then it has 5 inches and 5 inches. And then the perpendicular height, should we need that, which we do on this, is 1/4 of a foot. So notice they've messed with us again on our units. They're not all in inches. This 1/4 of a foot needs to be converted to inches. So what's 1/4 of a foot in inches? We can times that by 12 and see that that would be 3 in inches. So 1/4 of a foot, because a foot's 12 inches, we can divide that by 4, and we want to convert that into 3 inches. So we'll have all like units. Okay, then half of the two bases, 12 plus 4, and then times this perpendicular height of 3. So let's see, 12 and 4 is 16. Half of 16 is 8, or you can just type on your calculator. And then 8 times 3 for a final answer of 24. I've been neglecting my units on this. I should have had inches on those. You do get an inch in there, so it winds up being inch squared. And also just knowing when we do area, it's in square of the unit that you're using. So the area, or the space inside that figure, is 24 square inches. Then it asks us to do the perimeter. The perimeter would be adding up the sides. So we've got all those noted, 12 plus 5 plus 4 plus 5. So adding around, let's see, that would be 26, is that right? 26. And again, if we're just adding around the edges, it's regular, just in inches. All right, in number 11, we move to the circle. So we've got new formulas for the circle. Now, I noticed when I was looking through your homework on this that they use the pi button whenever we're talking about finding the circumference and the area of the circle. We use pi in that. Here's the two formulas you need for circles. Circumference of a circle is equal to pi times the diameter. So if we're looking at a circle, the circumference means the distance around the outside of that circle, like if you were putting a ribbon around a hat or just a belt around a waist. The circumference is the distance around that circle. And you do need to use the pi button. Now I know we know 3.14 is approximately pi, but it's got some round off error, and we've talked about how round off error can cause you to miss it by just a little bit if you're not careful. So you want to use the full pi effect. So all your calculators should have a pi button. So use the button on your homework and it'll make it come out more exact. So unless otherwise noted, use pure pi, the pi button, and it has more digits than 3.14. It's 1416, It goes on and on. So 10 digits on your calculator. Then times the diameter, which would be the distance through the center from side to side of a circle. Then the area of a circle is pi, again use your pi button, times the radius squared. So the radius is halfway, just here to here is the radius of a circle. So when you do number 11, on my example I have 10 centimeters. So for area, you use your pi button, and then the radius is given to be 10 squared. That answer should come out to be 314.6. And because it's area, you'll put units squared, so that's centimeters squared. Then for B part, for the circumference, we'll use our pi button. Diameter, if it's 10 to there, then it would be 20, 10 over here as well, or 20 for the diameter. So we multiply that on our calculator. It's a linear unit because it's just distance around something. So the circumference, distance around the outside, is 62.83 in centimeters for that one.